The total cost of operating a factory in terms of X units produced is given by the function C is equal to 0.5 X squared plus 15X plus 5,000. The average cost then is going to be modeled by A is equal to C over X. So the total cost divided by the number of units. So in part A, we're asked to find a function for the average cost A in terms of X. So I'm going to take C over X and just take the value of C, 0.5 X squared plus 15X plus 5,000 and divide it by X. To make things easier in my next part, I'm actually going to divide every single term by that X. So 0.5 X squared divided by X is going to leave me with 0.5 X. 15X divided by X is 15. And 5,000X, or 5,000 divided by X is 5,000X to the negative 1. I like this version better because in part B, we're asked to find how many units the factory would have to produce in order to minimize the average cost. Since we're trying to minimize something, I want to optimize that average cost function, which is going to involve finding the first derivative. So I'm going to go back to this one and take the derivative. The derivative of 0.5x is 0.5. Derivative of 15 is 0. And the derivative of 5,000 x to the negative 1 is negative 5,000 x to the negative 2. The maximums and minimums, they're going to happen when the derivative is equal to 0 or when it's undefined. So let's take a look at this function, clean it up a little bit. 0.5 is 1/2 minus 5,000 over x squared. Writing this as a single fraction, our common denominator will be 2x squared, meaning the 1 gets multiplied by x squared, and 5,000 gets multiplied by 2, so that's 10,000. The values of x that are going to optimize this function are those values that will make this derivative equal to 0 or undefined. If the derivative is equal to 0, then the numerator is equal to 0, making x squared equal to 10,000, and x is equal to positive or negative 100. Or we have this possibility of our derivative being undefined, so that would be x squared, our denominator is equal to 0, making x equal 0. So we have 3 critical numbers. Now within the context of this problem, we're trying to minimize the average cost. Having a negative value of x would mean that the factory would produce a negative number of units, and that's not reasonable. Having a value of x would create this average cost function right here to be undefined because we're putting 0 in the denominator. Means that the only critical number we have left is x equals 100 units.